So hello friends, my name is Neeraj Avinash, and in the previous few sessions, we have seen Docker in action, and we successfully built an Docker image and we Dockerized our Flask application. And now we also understand, in the previous session we talked about like what Docker is and why Docker, and what are the benefits of Dockerizing an application, and why it has been adapted as an industry standard. And many software companies are shifting towards the microservice architecture. So we know we do have a fair idea about all these topics, so we will not waste time on discussing on that. So let us today, so we will see one of the very important file while Dockerizing application, that is the Dockerfile. So this is here. So the Dockerfile, you can think of it as a blueprint, and it is a file where we put all the instructions that would be used by Docker to build our image. Okay, so the first line of Docker starts from the from instruction. So from is something like this line actually tells while building our application, Dockerizing our application, while building our image, so we need to have one base image upon which we will build and deploy all of the rest of our application code. So this instruction from base image, that suffices that purpose. So the base purpose of this from instruction is to direct the Docker to use this as the base image while building rest of the process. Okay, so base image, you can also think of it in a plain simple terms. You can think of base image as a foundation upon which, while in the real life also, like while you build your construct your house, you need to have foundation, you need to build your foundation. So base image is simply the foundation upon which rest of our application code would reside on. Okay, so there are lots of base images available. So we can use, let's say, Ubuntu, and we can tag Ubuntu like what version we are going to use. So let's say 20.04, and this next instruction is the working dir. So work dir, in your local machine, on your local development machine, definitely we organize our code in some sort of directories, some sort of working directory. So work dir is the same thing that directs Docker to treat whatever the directory name we are providing, to treat as a working directory, and all the rest of the processing like dependency installation and other things would be happening inside that directory. Okay, and then comes the copy command. So copy is like we are with this instruction set, we are telling Docker to copy from our current local working directory to the working directory inside in the container. So that is why this copy and this period dot denotes the working directory, current working directory on the local machine, and the working directory to the inside the container. And next we are putting this instruction, it run pip install, and this is actually with the run keyword, run instruction set. We tell Docker to run the command as if we are running on a terminal. Okay, and finally this expose. So expose is actually, this is very important, so let us give some emphasis on it, let us highlight it. So cause reason being, expose with the expose command, with the expose instruction, we are actually opening a port inside a container upon which our container would be able to communicate to rest of the world. So you can think of it as a small window, small hole inside the container, and we can specify multiple ports here as well. For example, let's say if we need to open expose port 80, 443, and let's say port 5000. So we can expose multiple ports. No worries, no worries for that. So that is perfectly okay. And not only this, we can also specify, like we are opening a port, let's say 5000, and that should listen only UDP protocol. So we can do that thing as well. No worries at all. And we can direct the protocol as well, like TCP and UDP and so on. Okay. And final step is our CMD instruction. So this CMD instruction, we are telling to execute the final program, to execute our program. What would be the entry point of our program? So this is very simple. For example, say on our local machine, if we need to run this our program, so simply we need to type in python app.py, right? So this is what we have instructed to execute the command as a final one, Python to fire our Python interpreter, and the script name app.py, right? So this is it about the blueprint of the simple Docker file, and let's see it in action. So before in order to do that, so definitely we have to build. So let's say Docker build. We will name it, we will give it a name, a tag name. So we will name it Ubuntu image 1.0 and a period sign, that reflecting that we are going to build from the current working directory, right? And hit enter, and let us see what happens. So it will throw an error. So let's highlight it and let's talk about that thing. So that would be, I think like that would be wonderful to see that. Okay, so we encountered an error and it is saying pip is not found. So the reason of this error is very simple, because our program is using Python, and we are trying to run this instruction with the pip with the run pip install. So actually all we are trying to do is we are trying to install our dependencies from requirement.txt file using pip. And since Python doesn't come pre-installed with Ubuntu, so that is why since Python is not installed, pip is not installed, so this is why this error came in. So in order to fix that, we can go, there are a couple of ways. So either we can install Python inside Ubuntu, or there is a better way actually. So the better way is something like, since Python is so much popular, so Docker provides an official image of the Python, and we can tag, for example, say if we need to use Python 3.10, and we can also direct to have some kind of our specific flavors like Alpine, Debian, or Ubuntu. We can direct it, no worries. So that is pretty okay, and you will get each and every information on Docker Hub. So you can select the base image as per your choice. So right now Alpine is actually a very lightweight. So this is very lightweight version. But the problem here is like Alpine, although Alpine is good for a small application, but since this is very lightweight, so when your application grows in size, so definitely it on production server it might cause a problem in the longer run. So the better way is to use there is a very lightweight and good thing, that is Slimbuster. So Slimbuster is actually a Debian based, but if you go for the original Debian version, so it will be around 900 MB or so. And while Slimbuster is comparatively very small in size. So now let us save it and try to build it again. So we will say again, but this time we are trying to build a slim image. So let's go that way. So we name our image as slim image, and we will again give it a version 1.0. Hit enter, and let us see what happens. So this time definitely if it is pulling from Docker Hub, the base image, slim image, because that was not available inside our local repository, local Docker images. So it is running the install pip install. So yes, our image has been built successfully, and let us try to run it. So let's say docker run, and we can provide the name of the container through which if we need to specify what should be the name of the container, so we can specify with the name flag, name option, and we will name it our container as slim container, slim cont, and we have to map the port. So we will bind the port, let's say 6000 from outside port, and inside our application talks on port 5000, and we have already exposed port 5000, and slash rm. rm stands for remove. So definitely, like when we close our container, so it will detach the container, it will destroy that. Okay, and our image name was slim image version 1.0. Hit enter, and now our container is running, and you can cross check it. You go to your Docker desktop, and you can see the slim image has been created, version 1.1, that the tag name is 1.0, and that is in use. And you can look at here, it is comparatively very small in size, around 129.45 MB, right? So this is the beauty of a slim buster. And if you go to container, so our container name is slim cont, we named it, and the image it is using, that is slim image 1.0, and it is listening on port 6000 on our outside world, and 5000 inside container. And you can also cross check other things, like what Linux distro it is using, and in order to check that, you can fire a command etc cat. Cat stands for the, if you need to print out the content of the file, so that is why we use cat. So I hope like everybody, you must be familiar with that. So cat etc, and we are trying to print the content of this file. So here we can see like it printed out the Linux distro version. So it's a Debian, but comparatively smaller in size. And we can also cross check here our Flask app. This is our working directory, and here you can see our application code is there. And if we go to the browser, and if we try to hit localhost port 5000, nothing happens. Why so? Look, just wait for a second. So let me cross check. Let me see. Okay, my bad. It is actually we bind port 6000 from outside world, so we have to change the port actually. Port 6000, localhost port 6000. What happens? Let me see. It is running port 6000, and we have already exposed port 5000. And what the problem is? What is the problem? Port 6000. Let me see if yes, it is running fine. So localhost port 6000, it should have run. Let me see what is wrong here actually. Let me see what is wrong here. What went wrong? What went wrong? If there is any wrong with our file? No. Our program seems to be okay, but let us try to change the port. We will try to bind our container on other port. Maybe port 6000 was busy. Port 7000 this time. us try it out. So our application is started running on port 7000, and now let us try to change the port 7000. Yes, so maybe like it could happen like our port 6000 was consumed by some other program on my machine. There is nothing wrong with your one, so I will when we change the port from 6000 to 7000, so that is running fine. So this is the importance of Dockerfile. So that is a blueprint, and oh yes, there is much more we can do, and we will in the coming few sessions, so we will see how to persist the data from inside our container to our local machine, so that cause container gets destroyed, cause it gets spinning again and again, it might happen. So the moment container gets destroyed, so all the data would be lost. So in order to persist the data, so that our data, for example, the logs are our data folder of your database, Postgres data or MySQL data. So we need to persist the data, so that it doesn't get lost. So we will see them in the coming session. So till then, like if you have any question or any confusion, so please do let me know, and I'll try to solve them as soon as possible. Till then, take care. Bye bye.